Okay, hi everyone, let's get started. I'm Matt Turck, welcome everyone. I hear there's actually quite a few new people here, so great to have you guys. For whoever is coming back, welcome back. I was going to say we have 3 great speakers tonight, but so far we only actually have 2. But hopefully the third one is on his way shortly. I think Sean, who's from New Zealand, said about the speaker who's not here, who's Australian. What did you say? Bloody Australian?
Bloody Australian.
But so the other thing is that today we're going to change the format a little bit. So for the people that have been here before, you know that we did one presentation after the other. Since we have a great group of people that know each other well, we thought we would change things up a bit. And so what we're going to do is each person here is going to have 10 minutes to talk about who they are and their company, one after the other, and they have some slides with some demos to show you. And after that, we'll jump into a panel format discussion. But as I say each time here when I start, this is a meetup. This is really meant to be an opportunity for you guys to interact with one another and with the speakers. So I'm going to only ask 1 or 2 questions at the beginning of the panel, and then it's you guys. So you can ask as many questions as you want, and have as much. And as long a discussion as you need. And there'll be 2 people with mics, passing mics around. So with that, Mike, do you want to start?
Sure. And I think I'm going to go show some slides to begin. So thanks, Matt, and thanks for having me here. I'll start by saying that in many ways, Metamarkets is very much inspired by what Bloomberg has done in the financial markets. I sometimes think of the financial markets as a mature data vertical. So all the things that we see now happening in other verticals, whether it be complex event processing, advanced analytics, column-oriented databases, things like KX systems, now we're sort of seeing those same approaches permeate other verticals. And I think the difference is with this rise of data science is it's really an economic change. Now with things like Hadoop, and many of the open source technologies that are out there, you can process large quantities of data even if that data doesn't have a high density of value. Before last decade, it was too expensive to process all this data, and the only place where the economics worked out where the cost of processing, it cost a nickel to process data and get a dime of value out of it was on Wall Street. But now that's shifting. So that's maybe a segue into what I do at Metamarkets. So Metamarkets is the company I founded 2 years ago, and Metamarkets focuses on providing data science as a service. And we started actually in the online media markets, but I guess maybe I'll just say a bit about the future that we anticipate. And I think, again, this is very much consistent with some of the themes that we've seen here on Wall Street. There's this digital mirror universe that's all around us of tweets and check-ins and point-of-sale devices and transit events. And all of these things that are happening, this Internet of Things is pulsing events into the cloud. And for a long time, many of those events were invisible. And I think what we're seeing happening increasingly is that this digital world of events, this pulsating digital nervous system of the planet is actually being made visible. And there are new technologies that can help us create value off of those streams. And Metamarkets is certainly interested in building technology that addresses these data streams. So, maybe quick what we do and why we think it's interesting. We sell data science as a service. Someone said recently that there's been all this talk about data scientists, and I think that data science is great. We're all here to speak about it, but we can't throw bodies at this problem. I think all of us, the highest calling that we can aspire to as engineers is not simply just to tackle problems with tools, but to actually build tools. So we all know there just are not enough data scientists out there to help make sense of all of this data and create value from it. I think all of us need to aspire to build tools that can help regular people who don't have PhDs in statistics from Columbia to create value off of this amazing wealth of data that we have. So, I'm not going to talk much about what we do in terms of our differentiators. You can look those things up. But I guess I do want to talk a little bit about what I see as the emerging big data stack. And there's Jeremy. Hey, buddy. Jeremy from Kaggle. I just texted your co-founder who's in Palo Alto and said, where is Jeremy?
It was like starting at 6:30.
Oh, okay, perfect. So, there's this emerging big data stack, and I think ultimately I sort of think of it as having 4 layers. And this is independent of what Metamarkets does. I think everyone has a set of processes they do. I wrote a blog post a couple years ago called The 3 Sexy Skills of Data Geeks. And in retrospect, I should have called it data scientists, if I'd known that was going to be such a hot meme. And I talked about munging, modeling, and visualization as the three skills. And that was really playing off of a quote from Hal Varian who said that statisticians will be the next sexy job profession of the coming decade. I think Hal got it mostly right, except that it's not just statistics, right? It's not just modeling. It's really important at this bottom layer here. Munging data is really hard. We all know when we work with large data sets, 80% of the time we spend is in structuring those data sets into a format that we can use and then put on something like Kaggle for a competition. But that ETL, that extract, transform, and load, that munging, is the coal mining of the information age. It's the dirty work that has to get done before we can get data that will fuel our analytics. So right now, the current data stack is kind of broken. It's sort of a Frankenstack. You've got Hadoop at the bottom. We're not even sure we need Hadoop. If we're doing continuous processing, maybe we could just do it in memory and get rid of that. Storage. Storage is broken. That's why we have all these legacy databases just don't scale. So we have the rise of NoSQL and other different storage options. Finally, at the analytics layer, it's still very custom. You've got some things that are out of the box, but let's face it, if you're doing analytics at your company, you're rarely just buying SAS Enterprise Miner and plugging it in. And then finally, visualization. And this is where a lot of focus has been because you can see it, right? And there's a lot of startups that are creating cool visualizations on the web. Unfortunately, that's not enough. It's very superficial. So I think if you're going to have a real solution in your company, you've got to have a full stack because your visualization that experience can only be as fast as the engine that's powering it, right? You can have a Ferrari chassis, but if you don't have a Ferrari engine, it's not really much of a Ferrari. So obviously, at Metamarkets, we're attempting to achieve this integrated stack. Certainly companies build this on their own as well. If you look inside LinkedIn and Facebook and Google, they've got a similar stack. But not everyone is Facebook, Google, and LinkedIn, Silicon Valley firms. And not everyone is Bloomberg, who I'm sure has a stack very much like this. So, but there's some really interesting stuff going on in the data space. It's not just about data. I think it's actually about a lot of this is being driven by, and not just the Internet of Things. I think it is about a new kind of computing substrate that we've seen emerge in the last couple of years, and that is the cloud. And if you look at the growth of the cloud, it is just shocking. I mean, Amazon's Web Services is $1 billion business. They grew by 80% last year, year-over-year growth. They will definitely be over $1 billion in services this year. And what's amazing about that is, I never got a phone call from Amazon. I never talked to a human being at Amazon until our company was spending $50,000 or more a month there. And I took a survey of CTOs a couple of months ago, and I asked in a room of 28 CTOs, how many of you here are using Amazon Web Services? And every single hand went up. So this is really the future of computing. This is the future platform upon which, it's the operating system upon which enterprises will put and consume their software, and usually as a service. So one thing I know that Sean's going to talk a bit about, and I thought maybe this may meld into what you mentioned a bit later. So here I'm naturally mentioning this data store called DRUID. That's something we've developed at Metamarkets. It's an in-memory database that scales on the cloud. But I think more importantly is sort of this landscape of what really matters in the big data space when you're talking about the persistence layer. I think there's really 2 dimensions of interest. Obviously scale. Scale matters, but that's the x-axis here. And you can see, I think of big data as being defined as data that is distributed, right? Because If you think about the point at which you've got a hard disk, I think of small data as data you can fit in memory in Excel. I think of medium data as what you can put on a single node. And big data ultimately is data that is distributed across many nodes. That's the only way you're going to get into the petabyte or multi-terabyte realm. And so Hadoop has solved the scale problem. Hadoop, you can crunch petabytes of data with Hadoop. I think where the axis of competition in the data space in the coming years is going to be all about speed. And there's a couple of bands here that I think are worth looking at. This band at the top here in terms of speed is the time of milliseconds to seconds. I call this human time, and many other people have called it human time, or Larry Ellison calls it at the speed of thought. If you don't have systems that can respond in that band, then they may as well be batch. They may as well be not real time. And people are going to go get a cup of coffee while they wait for your system to give a response. So the goal really is to create systems that allow for an interactive analytic dialogue with your data. That's the holy grail. And when data gets big, having that interactive analytic dialogue gets difficult. And there are some offerings that are attempting to stay into that space. But I do think it's really going to be about speed. And you see like MapR, in fact, is a Hadoop competitor. They're about making Hadoop faster and more efficient. So I won't say too much, but if you're interested in knowing a bit about a natively cloud architected database that scales and is really fast, you can check out this thing we created called DRUID. We've written some blog posts about it. But the bottom line is, when you architect in the cloud, you can do things. You really have three advantages. One is flexibility. So nodes can go down. You can repair them easily, and there's no disruption of service. The second is parallelism. One way, parallelism is a force multiplier. It's like leverage. And so when you have massive parallelism, you can actually crunch lots of data very quickly. And the final thing that really separates this, and I think ultimately this is a trend we'll see for all data stores, is that most data that is related to a human activity will end up in memory, in DRAM, over the next couple of years. There's no reason for us to have these disk-backed databases when the cost of DRAM, the cost of memory, is subject to the same sort of exponential decay forces that we see with computing and bandwidth and other forms of storage. And then this is just some pictures, some pretty pictures. But rather than show you a static picture, what I'll do is actually show you a quick picture from the Metamarkets dashboard. So did that come up? OK, great. So this is just kind of showing off some of the neat things we can do with modern web browsers. These are SVG rendered plots that are generated by a framework called D3.js, and we've built an event framework on top of that. I think one of the take-homes here is that, and what are you actually looking at here? Well, this is not a Wall Street, NASDAQ exchange. This is actually data that's drawn from real-time advertising exchanges. So every day around the world, there are 100 billion advertising microtransactions that occur. And these are the types of things if you ever open New York Times on your cell phone and you wonder why it takes so long to load, what's actually happening in the background is there's an auction event where an advertiser is bidding for the right to show you a small little display ad. And that can take 600 to 800 milliseconds for that auction to go through. Metamarkets sits on top of these streams and provides analytics to the exchanges and as well as publishers like Demand Media, Financial Times. We actually spoke to Bloomberg. But the bottom line is this is a huge event stream. And the cost of each of these transactions is very low. I mean, each ad that you see on the web is worth fractions of a penny. So you've got to have an architecture that's cheap, that's commodity-based, that's scalable. And that's where the stack that I showed comes in. And the idea here is that we're moving from this web of documents. With Timothy Berners-Lee talked about the original conception of the World Wide Web was this web of documents. Well, we're moving to a web that's really a web of data streams, right? Web pages are no longer these static elements. Web pages are actually applications through which events move. And if you use Gmail or look at our application or others that are out there, they are essentially these applications where you ship JavaScript and then data moves through those applications over time. I think that's the new paradigm for web services. So I guess, sort of final, I'll just show off actually what, and when I said I was inspired by Bloomberg, what Metamarkets has built in terms of our interactive dashboard for data really is a way to sort of explore multi-dimensional time series data in a very natural and intuitive point-and-click interface. And what you can see here is I'm actually looking at the Wikipedia edit feed. And so I can actually look and see for English web pages, what are the top web pages edited over the last 24 hours, or the last week actually. And I can sort of point and click and drag, and I can zoom in and out. And all of these queries that you're seeing here are actually being run in real time on that back end. And I can even compare, different, two different pages. So the idea here is that, data science doesn't need to be something that you need a PhD to do. Many of the questions we ask of our data are just about relationships between your data set. Most executives and decision makers are asking, I just want to know, what were the top products that sold in this region of the world over the last 2 weekends? You can express that in English. There's no reason why companies need to have this data bureaucracy of decision maker to data analyst to database administrator, pull the query, pivot table, all the way back. Those latencies really stretch the patience of even an organization, and they really slow people down. And a lot of the friction is around the scale. But if you can get something fast, the average, I wouldn't say the average Joe, but a decision maker can sit in front of this dashboard and actually get answers. And to show off that it's not just limited to one type of data, here I've also got data from the Twitter that we pulled in. And I can sort of, again, explore this and look at different dimensions here, different languages. And I also, if it doesn't, if I'm stressing the browser here, because I've got that other one here, I'll show the last one, which is, we actually use this to also monitor our own data. So we dog food. So all of the Metamarkets servers are instrumented with event emitters that tell us the health and the memory pressure and the compute of all of the nodes. So we actually, every day are tracking across all of our machines the status of how things are working. And it's good because that's actually the thing that I check more frequently, because I'm certainly not looking at my customers' data. I don't even have access to it. So it's good for us to have something to dog food with. So with that, I guess I'll turn it over to my data science colleagues. But thank you for hearing a little bit about what we do at Metamarkets and data science.
Thank you very much. Jeremy?